Hello, students. Today we're going to talk about congruent figures. That's really exciting.
That is, I think congruent means that they have to be the same.
Oh, I think we've talked about congruent before. And things
We
that are
have.
congruent have the same size and shape.
It's true. You could think of them as a transformation like this one is.
Oh, so it's
That one
saying,
says it's translation,
mm,
1, -2, which means right 1 and 2 down. So there's no like actual numbers on this page, but we'll pretend that it's 1
sure.
to the right and 2 down,
Yeah, I buy it.
even though it looks
Nope,
more than 1
nope,
to the
nope,
right.
nope, 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 nope. It's good. It's good. I buy it.
So
It
all
makes
the
sense to me.
congruent things, yes, it makes beautiful sense. So I'm going to write down all the angles of the original triangle.
Hmm.
Angle A, angle B, and angle C.
I'm going to write down all the sides of the original triangle.
Ooh, you're bold.
I know.
So if we are looking this, if we say A, B, C goes right 1, down 2, which that's obviously to scale, that means A goes to D.
Hmm.
And if B goes right 1 and down 2, then B matches up with E. I like how you went down 1 and right 2, which is the same thing. It doesn't matter. And then C does the same thing, right 1 and down 2. By the way, we're kidding. It's not at all to scale, so don't get confused about that. So A matches up with D, B matches up with E, and C matches up with F.
And then we can do the same thing in terms of, well, if A goes to D, the A is going to go to the D here, and then the B is going to go to the E. That's just kind of a way to double check, especially since these appear to be isosceles triangles, that we're lining up the right sides so that these things correspond with each other. When we're talking about parallel lines and transversals, we talked about corresponding angles having the same position. And here, these would be corresponding sides because if they are set in the same orientation, AB and DE would have the same position as well. So that means that BC would go with EF, and AC, let me switch colors again,
I like all the colors.
would go with DF. Cool.
And I wrote down the bottom congruent corresponding parts because when figures are
Ooh, yeah.
congruent, all their parts are congruent, like the parts that match up. So that's what we just listed as all the pieces that are in fact congruent.
So in kind of like non-math figure words, if you have two things that are the same, all the pieces that make them have to be the same too.
Mhm. Well, all the pieces that match up, yes.
Yep.
And that's basically what this is saying. Congruent figures have the same size and shape. You can slide, flip, or turn. So those are transformations. So basically, to get congruent figures, you can do some sort of rigid motion. That would be the slide would be a translation, a flip would be a reflection, or a turn would be a rotation. And we're going to figure out how to figure out if these figures are congruent. I like that you wrote rigid and with an exclamation point. That's exciting.
Yeah. So these again are all rigid motions. They're rigid transformations. We've talked about non-rigid transformations, which are things that do not preserve congruence. We're only going to look at one of those this year. That's going to be later in the year.
And it's interesting they picked slide, flip, turn instead of translate, reflect,
Yeah.
and rotate, which are things we've already talked about.
Looking at this, this is just kind of defining what congruent figures are. We've already talked about this somewhat. And then we have, are these dodecagons?
1, 2, 3,
Yep.
4, 5, 6, 7. Yes. I don't want to write all those parts though.
Yeah, I don't. So let's just say, I mean, these are all.
He's just moving on. Moving
Yep.
on. All right. So this one says the wings of an SR-71
That's a blackbird.
something aircraft suggest congruent
Oh,
triangles. Oh, blackbird. There we go. What is the measure of angle D?
blackbird
So
flying in the dead of night.
yes. So we can see that B and E match up. B and E. And we can see that it looks like there's like a reflection here. A line of
Yeah,
reflection.
I think I'm gonna have to
By
go
the
with
way, the
that.
reason they're not using those words of reflection, rotation, translation is because those are actually later in the book than this section is. I
Oh,
realized
that
that.
makes sense. Or I
So
mean that.
since we're reflecting, um, C and F are going to match up.
So does that mean that if I'm thinking about this in terms of angles, this suggests that 75 degrees would be F because those match up and would be congruent?
Yes.
Okay.
And then we know that the angles of a triangle add up to 180. So we've used 105 of them.
Hmm.
So we have 75 left.
Oh, that's kind of cool. So that means that that's got to be 75 degrees and that one's got to be 75 degrees as well.
Right. And to reiterate, those are 75 because the angles of a triangle add up to 180. They're not
Hmm.
75 because C and F are 75.
Correct.
But logically, it makes sense that we would have isosceles triangles in a figure like this because it's symmetric about the middle. That line of reflection that I drew actually goes right up the middle of that airplane, and the two sides are the same.
Cool. All right. Are the triangles congruent? So we know that triangles are congruent if all sides and all angles. I'm going to add one word to this. Corresponding. This is an awkward construction. I don't even know how to fix this.
Just
I'm
write
just,
congruent. Just write congruent afterward.
there we
So
go.
you're saying all corresponding sides and all corresponding angles are congruent.
Yes, there we go. I just swapped these words, which makes that interesting, but that's okay. Okay, I'm going to identify that B and D appear to be corresponding because they are marked as congruent.
So since those have 2 marks, those are congruent.
They are. So angle
Okay.
B is congruent to angle D. I also know that angle C, sorry, angle A and angle E.
I'm
I
pretty
can't
sure you
read
said
letters
angle D
sometimes.
was angle F before, so it's fine.
Angle E are congruent. So we're looking at A goes with E, B goes with D. And then I noticed something here that angle BCA and angle DCE are vertical. And
Why are you saying 3 letters for those, but we used 1 letters for the other ones?
well, if I say angle C, it's confusing because I could talk about that angle C or 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 that angle C. That's a lot of angle C's.
That is.
So rather than do that, we use 3 letters to be a little bit sure. And you could do that for these ones too. I could describe angle D as angle, I'm an eraser, there we go, angle CDE, and that would be totally fine. It's a little bit more careful to name angles with 3 letters all the time, but we as humans tend to be a little bit lazy. And if
Hey,
we don't,
mathematicians.
yeah, one of the big goals in math is to find ways to be strategically lazy. Um, but I do notice that these are vertical. So
Mm.
therefore, we know vertical angles are congruent.
Ooh, that's right. We proved that.
So we've got angle BCA must be congruent to angle ECD. Hey, we got all 3 angles with all 3 angles.
That's good. Now we just need the sides.
Okay. I noticed some things in terms of being marked. That angle, side AC and side CE are both 6. And if their measures are the same, therefore the segments are congruent. Technically, that's by the definition of congruence, but that's one of the silly things that we tend to obsess over as geometry teachers that we don't care about so much.
Could I have said AC and EC?
You could have. It doesn't matter which side we're talking about in terms of the order for segments because these are non-directional.
Got
And that might even be a little bit nicer because then you're also matching up that A with that E a little bit more clearly.
it. Mm.
Although both of those mean the same thing. So I'm going to mark those with 2 tick marks. Why do you think I'm using 2 tick marks here?
Is it because there's one already used on AB and ED?
We do. So we've got AB and DE, which are congruent because they're shown with a tick mark already in the picture. And then we've got 1/3 side to look at, and we got, oh, 4 and 4. So I'm going to mark those with 3 to say that BC is congruent to DC. And now I think we're in good shape.
So we found all three sets of angles all corresponding angles are congruent, and all corresponding sides are congruent.
We do have one tricky thing we have to do, which is to make sure that we're matched up in the order. So if I start with A, we said that A goes with E, so I'm going to start with E on the other side. And then if I do B as my second angle, that matches up with D, so I'm going to put that here. And if I do C as my third angle, it matches up with C in terms of the triangle names. So we could say that triangle ABC is congruent to triangle EDC.
So is it fair to say if I pay attention to the kind of tick marks, I can figure out that order? Because you went like AB, so you have to go ED, and then you went BC, DC, and then your last piece. So if I read that as 1 mark, 3 marks, 2 marks, 1 marks,
That'd be
3
good.
mark, 2 mark.
Yeah, and you can go in the opposite order, and that'd be totally fine. Triangles are a little bit easy in that sense because as long as you line up the angles, it doesn't really matter. Quadrilaterals, you have a couple different orders you could choose that will change things around a little bit. But yeah, that's it.
So this next theorem we already talked about in this video, because what we talked about was we already had 2 sets of angles that were congruent, and because of the 180 thing, this was that blackbird.
Blackbird flying in the dead of night.
Yes, aircraft.
It's a stealth
Then,
A plane, so you can't see it.
then the third angles have to be the same, and that's because of the whole 180 thing. So if you know that the measure of angle B plus the measure of angle A, I said those and wrote those different. I'm sorry, I was confusing. Plus the measure of angle C equals 180, and you know the measure of angle D plus the measure of angle E plus the measure of angle F equals 180 because those are triangles. Well, those are both equal to 180, so those have to be equal to each other.
We know that if these are built of pieces that are congruent, you can just play swapsies because those things added together mean the same thing.
Yeah, you could also channel your inner algebra 1 student and subtract those equations. And you'd have the measure of angle C minus the measure of angle F equals 0. So then the angles are the same.
I like it.
So we kind of danced through a little proof there, but basically it's if 2 angles match up with 2 angles, and we're talking about triangles, the third angles have to be the same.
All right. So here we have basically the same thing we did a little bit ago, but they're asking this as a proving thing instead of kind of less formal description. So what Mr. Butterworth is doing right now is writing down the stuff that he knows in this problem in order to kind of figure out what's going on here.
So I need all 3 sets of sides to be the same and all 3 sets of angles, the corresponding ones. So let's start with the angle piece. Since we know that we already have 2 sets of congruent corresponding angles, that means the third ones have to be the same.
Yeah, because they add up to 180.
Right.
Yeah.
And so that's going to be MNL. And so that would be this little guy. And then ONL. ONL. And that would be this little guy. It's hard because the picture's so tiny. And then with the
I got you.
With the sides, we got L, M, and LO. Those have 1 mark. MN and ON, those have 2 marks. Well, the last side of both figures is LN and LN. I'm pretty sure since those are the exact same segment, those have to be the same.
Identity.
That's true. We could also call that the reflexive property. Probably could call it the symmetric property also. So
Yeah, there are lots of properties that go with that. By the way, that was also a My Cousin Vinny reference, which I highly recommend as a movie. Um, but I tend to do, I don't know why I always do identity marks with 3 tick marks. Uh,
You
I,
always do?
I always do. Uh, in,
Interesting.
so if that always ends up being the one, I'll do with 3. Even if it's the first thing I marked, I'll use 3 for that one. I don't really know why.
Interesting. That's fascinating.
But to me, it looks like we've got 3 angles and 3 sides that are each congruent to a matching piece. And that they line up in the same way that the proof statement is, that the L goes with L, okay? M goes with O, N goes with N. Uh, that seems like we've done our job.
That is true.
All right. So this is kind of a matching up corresponding pieces game. I
I
think
like
this would be a good one to at least pause, or do we want to have them do this entirely on their own, Mr. Butterworth?
I think they should pause
Mm.
and we'll put in some questions here, but they should try to fill in as many of these as they can. And if you can't, we'll put down the answers. And if you still don't
Mm,
understand, you should talk to us about it.
that
But
makes
it's your
sense.
responsibility to talk to us.
I'm gonna start with 4 if you want to start with the ones that are less
Okay.
wordy.
So QX and NY are going to be the same. I can just look at the order of the letters, and then Y and X are the same. Again, the order of the letters. So QX and NY. And then TA is here. And that's for, you could write it as RO or OR, it doesn't matter. And then angle R and angle T. I'm only using one letter because I'm assuming that these are distinct figures. If they were overlapping like in the previous slide, we would have to use 3 letters, but that wouldn't be too scary. And then in honor of Mr. Daniels, we have band luck. So we have angle U and angle A are going to be matching up. D, B, and KL are matching up. And then NDBA, that sounds scary, but if you just read it as NDBA, then that's going to be CKLU. CKLU.
Clue, clue.
That sort of does
Uh,
it. What are you doing?
so the first thing I did was I matched up the letters that they gave us in the statement. So A goes with I, P goes with E, and since those are congruent, the third angles M and T have to be congruent as well. So that's part A. Part B, it identified angle A and angle P. It's asking us about angle T, which is in a different triangle. So one of the things that I'm looking at, so we've got 52 plus 36 plus the measure of angle M is going to be 180. So that would be 144, 94, 92. Did you do that math right, Mr. Butterworth?
88, 92. Yes.
Cool.
That's fascinating that we did it slightly different ways.
Oh, because you added them and then minus?
Yeah.
Yeah. I also know that 180 minus 36 is 144.
Oh,
That's one of the facts that's in my head. So it's
mm.
anyway. So I subtracted those, got 92, and then based on my original statement that angle M is congruent to angle T, that must mean that the measure of angle T is the same as the measure of angle M, which is 92.
Now, if students found this super confusing, would it be a bad idea to just draw any random triangle they want
What? You're drawing a triangle? That's amazing.
and mark things? So, like A and I are the same,
Hmm.
P and E are the same. And then it says A is 52, P is 36. So you could say, okay, 52 and 36 are also over here. And you could think about it that way.
I
Would
like
that
it.
be okay justification for a quiz also if they were kind of drawing things that way?
I would be fine with that.
Okay.
That's really good thinking. I'm a huge advocate for always drawing a diagram, almost no matter what the problem that we're looking at. Just because, if nothing else, it shows that you understand where things go. It shows that you know how to label things correctly, or that you know how to label things in an understandable manner. All right, I think that's it, Mr. Butterworth.
I agree. I think we done great.
Woohoo!